electrophile and a nucleophile, and also its reactions. So we will start with dictionary meaning of phile. It is a suffix and it is a combining form. A thing having a fondness for a specific thing is called phile of that. So here it is, main thing is fondness. So let us take electrophile. Electrophile is defined like this. A reagent that takes away an electron pair is called electrophile. So electrophile is having a fondness of an electron, but not single electron, it is electron pair. So which will have the fondness for electron pair or electron, it should be a positive charge. So electrophile is represented like E plus, okay, and we can say it is electron seeking, okay. Electron seeking means some other element or compound should have a pair of electrons or lone electron pair, okay. So this electrophile takes this not single electron, the whole lone electron pair, okay. Then we will see the examples of electrophile. So okay, examples, two examples you will see. One is, we will take some ion, that is Carbo Cation is CH3 plus is a carbo cation, okay. Cations will have positive charge, so it is carbo cation. So let us write this with some more clarity. So it has got 3 covalent bonds and a positive charge on C, okay. That is, further if you write with the electronic configuration also, write like this. So here hydrogen, here one hydrogen, here one hydrogen. See, carbon is supposed to have 4 electrons. This dot represents electron belonging to carbon. 4th one is not there. That means this will have a positive charge, whereas this crosses belongs to hydrogen electrons. So this kind of ion is an electrophile. So for a bond, covalent bond, it needs 2 electrons, so it will take always a pair. So another example is, we will take a molecule, I will take this group R3C-X, okay. We will take example of CH3Cl. So let us expand this. It's 3 H's and 1 chlorine. So how this is having a positive charge? If something should have a positive charge, then only it is electrophile. So for that, and it is molecule is supposed to be a neutral. So let us see how this can have a positive charge. For that, we will recollect the electronegativity, the tendency of an atom to attract electron to itself when combined in a compound. So that is electronegativity. So let us take carbon 2.5 and chlorine is 3. These are the values of electronegativity of carbon and chlorine, okay. So let us take the covalent bond of carbon and chlorine, okay. Other things not necessary. So this has got one electron, this has got an electron and formed a covalent bond, and this electron, you take any of this one of these electrons, it will be going around carbon as well as chlorine. Let us take this electron. It is going through carbon, then it is going through chlorine also. Then only it forms a covalent bond. See, the electron is negatively charged, and because this, for carbon, electronegativity is very comparatively less to chlorine, so electron is less attracted here, so it quickly goes around this carbon. Chlorine is more electronegativity, it will have more attraction to electron. Here it takes more than this time, and then it goes around the chlorine. So from outside, if you see, electron is less time around carbon and more time around chlorine. So this looks slightly negative compared to this positive. Why we have to put delta is, delta means it is a very small charge. Small charge means it is less than electron charge. Electron charge is the least, okay? But this will be smaller than electron charge. You cannot get electron charge smaller than electron charge by just dividing electron. It is all not possible. But in this kind of situation, you will get a charge which is smaller than charge on the electron. But it is the difference you will notice. For this reason, this carbon will have a slightly positive charge because of this molecule, okay, acts like a electrophile. Okay, so this also we will see in an example. Okay, so now we will see nucleophile. A reagent that brings an electron pair is called a nucleophile. Okay, then only it can search for a nucleus. Okay, so for that, examples we will take. So in these examples, we will see one ion, that is hydroxyl ion we will take. So let me write the detailed diagram of it. Oxygen 1, 2, 3, 4, 5, 6. We will take one more electron also, H. Okay, so this is the hydroxyl ion. Negative charge on this means one electron is extra. Instead of 6, it has got 7 electrons. So this is negative charge. It will have a carry negative charge. So this has got 1, 2, 3 lone pairs of electrons. So it can attract or it can attack a nucleus. Okay, nucleus is positive charge. So this is an example of nucleophile ion, hydroxyl ion. Then we will take another one, carbo cation. So I will take R3C category. Okay, so we can put or we can represent this R3 with a colon. This is electron pair. Okay, so I will take example of CH3. We will write like this. Okay, so this represents carbon is having 3 hydrogen atoms bonded to it, then 1 lone electron pair. So this will see, carbon is having instead of 4, 5 electrons are there. Hydrogens are okay. So it has got a negative charge on carbon. Okay, so this kind of ions are a reagent are examples of nucleophile. And we will take one molecule as an example. Molecule, I will take very general one, water. Let us draw the before that electronegativities we will draw. Electronegativities of hydrogen is 2.1, oxygen is 3.5, Let us draw a simple diagram of water. Two hydrogen atoms and one oxygen atom. Let us take one hydrogen and oxygen bond. It will have two electrons. Okay. And here also two electrons. In addition to that, it will have two more lone pairs of electrons. 1, 2, 3, 4, 5, 6. Which is okay. This will categorize into nucleophile because it has got lone pair, but there is no negative charge on this, but it will have a negative charge. You know, water molecule is having a dipole. Why dipole? For this reason only. Hydrogen electronegativity is 2.1, oxygen electronegativity is 3. Oxygen electronegativity is 3.5. Let us take only this bond. Like earlier, this electron will go around this as well as this oxygen. So because of less electronegativity, the electron will go around this faster, and oxygen will take more time. So this will have slightly negative charge, this will have slightly positive charge, like earlier I discussed. This description is only for explaining purpose. This is not a real thing. Okay, real thing. Okay, so because of this, if we take water molecule, it will have a slight negative charge on this, something similar to these ions. Okay, so that way it is qualified as nucleophile.